In this video, we are going to be talking about the contact process. Okay, the contact process. So, what exactly is the contact process? So, the contact process is more like the industrial manufacture of sulfuric acid. Okay, the industrial manufacturing of sulfuric acid. So, again, please feel free to pause the video. You can write these reactions and reaction conditions and just flow with me. So this is the industrial manufacture of sulfuric acid, and the reactions which are involved under the contact process are these outlined here. Now, this acid, sulfuric acid, is an inorganic acid because we're not seeing any carbon atoms present in it. So you can be very well sure that it is also a strong acid. Usually a lot of inorganic acids are strong acids. They are able to ionize completely. That's the reason why sulfuric acid, if it ionizes completely, we can simply write it like this: 2H plus and SO4 2 minus. It is able to undergo complete ionization. And once it ionizes completely, it's going to release 2 hydrogen ions and 1 sulfate ion. So these 2 hydrogen ions released are what are called the basicity of sulfuric acid. So basicity is just simply the number of hydrogen ions which an acid can produce, which an acid can release. So the basicity of sulfuric acid here is just 2. If I'm given hydrochloric acid, which is an inorganic acid, another strong acid, if it ionizes completely, it's going to be H plus and CO negative. You're only going to see 1 hydrogen ion there, so the basicity of hydrochloric acid is just going to be 1. So that's just what I can say between sulfuric acid, about sulfuric acid. It's a strong acid, it's inorganic, this is its basicity, it can ionize completely, just like hydrochloric acid can as well. So the reactions may be shown as follows. So you're going to see that we are getting sulfur, and sulfur is S8. It's a solid at room temperature and pressure, and it is polyatomic in nature. That is, it is made up of more than 3 atoms. Okay, made up of more than 3 atoms. So S8, once reacted with oxygen, what we're going to have is sulfur dioxide. The sulfur dioxide produced undergoes oxidation again. It's reacted with more oxygen to form what we're going to have as sulfur trioxide. Okay, so don't just like try to take it as addition, like 2 plus 2 giving us 4 here. No, atoms combine in very, very specific ways. So when sulfur dioxide reacts with oxygen, what we're going to have is sulfur trioxide. The sulfur trioxide is going to be obtained and reacted with water. Now, once the sulfur trioxide is reacted with water, we have an intermediate compound produced. And the intermediate compound which is produced here is oleum. It's H2SO7, oleum. Okay, oleum. And it is from this oleum intermediate that we're able to derive our sulfuric acid from. That's the whole reason why this oleum is now just going to be diluted, is going to be just reacted with excess water. And once this oleum has been reacted with excess water, what you're going to have is now sulfuric acid at the end of the day. So oleum is more like an intermediate compound that is formed anytime sulfur dioxide is reacted with water And when this oleum again is more reacted with more water, what you're going to have is sulfuric acid. So these are the steps. What difference though do I wish to emphasize? Oleum is H2SO7, sulfuric acid is H2SO4. So don't try to interchange these values, the 4 and the 7. Leave them as they are. Of course, just like many processes like the Haber process, the Oswald process, there are always some reaction conditions for these things. So the catalyst here is vanadium 5 oxide. It's not just like vanadium. No, it's a compound. It's an oxide of vanadium, vanadium 5 oxide. Temperature range 450 degrees Celsius to like 500 degrees Celsius. And the pressure, atmospheric pressure, it's very low. And that's just like 2 atm. If you are able to explain the reactions of the contact process and also include the reaction conditions, then you're going to be very well and good when it comes to describing the contact process. And not forgetting, this is an inorganic acid and it can ionize completely. The number of hydrogen ions which it was releasing, like in this case too, is its basicity. For hydrochloric acid, it's like it has a basicity of 1 because it is just releasing 1 hydrogen ion. And these have lower pH values of approximately 1 to 2, making them very, very strong acids, like I'm just from explaining. So that's the contact process for it.